So now we should get a sense of what it means for them to be independent versus dependent, where again, in 8.2 we're going to focus on what these independent things do, whereas in 8.3 we'll look at what the dependent ones do. And for independent samples, the name kind of tells you what we're looking at. We are looking at samples where there really isn't any connection at all from one data set to the other. They are, in a sense, completely separate objects. So, examples of this would be things like those types of cars, or the sloths and the koalas, where the cars have no real connection between each other, except maybe the comparison you're trying to make, and the fact that they're vehicles that you're interested in. And sloths and koalas, you can't possibly make that sort of connection to other than through this test, because their natural habitats are on very different parts of the world. Now, when we're talking about these things as independent, they are still, in a sense, brought together by the context of the test we're going to run to compare them, but beyond that, they're separate entities. They're their own things that, for whatever information we're looking for, we have brought together for the purpose of increasing our knowledge about their potential for comparison. On the other hand, we're looking at dependent samples, where other words for dependent samples are matched or paired samples. We are looking for things that are connected. We're looking for things that are in some sense directly connected from one sample to the other. The most traditional dependent sample, and I'll say that probably call these paired more often, because paired or matched is actually a bit more, I'm looking for, exacting and descriptive for that relationship than the complementary language of dependent-independent, in my opinion. But the most natural example, and one we'll see a lot, is a before and after study, where the dependence relationship, the connection between the samples, is that you are looking at the same object, person, animal before something is done and after it is done. Because each element in the sample corresponds to the same thing in the other sample, as it were. It is the person before you do something to them and the person after you do the thing to them, to specifically see what effect happens. You're specifically looking for some kind of effect. This is what you might consider an experimental study, as it were, to call all the way back to the first chapter. Now, for our purposes, the easiest way to tell if something is not dependent, if it is not paired, is if the samples do not have the same size. Because for paired samples, we need an exact matching down the line, thing to thing. If one sample is bigger than the other, you cannot possibly match those extra things from the one to the other. There's nothing to connect them to. So that would be a dead giveaway that they are not dependent. It's not the one that is guaranteed. I think the word for this is it's a sufficient but not a necessary condition. It's been a while since I thought about that language, so I might have that backwards. But the point is, if you see two samples of different sizes, it's kind of a dead giveaway that you can't deal with this using the dependent assumptions that we'll talk more about in 8.3. For now, though, we're going to move on to actually looking at how we can perform some of these tests in terms of our independent t-testing approach. For two samples, looking at means, which is a mouthful, and it will continue to be a mouthful for the rest of the section, but we'll see that there are some more efficient ways to think about this than what the book might want you to do. Anyway, that's next.